Okay, I wanted to give you some help on the homework problems that were assigned for page 244. I'm actually going to do 3 problems, one from each of the sections. So this first problem I've chosen is number 8, and as you can see, we're graphing quadratic functions. And this first example, the function does not contain the linear term, so we talked in class about what that means for the graph. Number 1, it means that we have symmetry. The graph will be symmetrical around the y-axis. So in other words, when there is no linear term, the AOS will be the y-axis, or we could think of it as the line x equals 0. Okay, so here's my AOS, just as a reminder that the AOS splits the parabola into 2 equal parts, and the AOS always goes through the vertex. Well, when there's no linear term, the vertex is really pretty easy to discover. It's just the constant, in this case -3, on the y-axis. So my vertex will be the point 0, -3. Alright, so we have identified, we've plotted 0, -3, the vertex. I notice that the a term, the number in front of x squared, is positive. So one other observation I made is that this parabola opens up, meaning that the vertex represents the very bottom point of the parabola. So in specifics, I have a minimum value, and this is not asked for in this problem, but I'm just reviewing just a little bit. There is a minimum at -3, which is the y-coordinate of the vertex. And we'll talk more about that when we get down to the bottom 3 problems of this assignment. Okay, so basically I'm ready to start plugging in numbers for x. And really, you can choose any numbers you want. You would not be wrong, for example, if you let x be 1. And you just have to work with fractions, which is okay. We would have 1/4 minus 3, which would be -2 3/4. So you would just have to approximate where you think -2 3/4 is. So, you know, roughly right in there, just where you think it is. And then, of course, because of symmetry, we have a matching point on the other side of the AOS. You may have also noticed that our denominator is 4, and so it sometimes is a good idea to choose multiples of 4 in this case. Whatever the denominator is, you would choose multiples of that number, and that helps you stay away from having to plot fractions. So just a suggestion, if I do let x be 4, 4 squared is 16, and 16 times 1/4 is 4, and then 4 minus 3 is 1. So I have the point 4, 1, and then the matching point would be 4, or -4, 1. Okay? And I know in class the other day I said, well, I like to build from the inside out, and that is fine. But here's an exception to that. If you choose, if you want to, and you have a fraction that is your a term, the number in front of x squared, choosing multiples of the denominator will help your graphing go a little bit easier. Okay, so for example, it's not a multiple of 4, but another good number to choose would be if x is 2, 2 squared is 4, 4 times 1/4 is 1, and then 1 minus 3 is -2. So I know that -2, -2, and -2, -2 are also on this parabola. Now, you didn't need this many points. You only need 5. I'm just throwing out some extra examples just so you'll have an idea of how to generate points on the parabola. So that's what your answer for number 8 should look like. All right. Now in the next set of problems, you do have the linear term. In this case, the linear term is 6x. So that creates a little bit more work for us. Our first step is to identify the AOS, and I showed you that to find that we're going to do the opposite of B over 2A. Well, you need to understand, well, what is A and B? A is negative 3/4, B is 6, and of course C, not needed for this calculation, is also 6. Alright, so let's see if we can identify what the AOS is. It's the opposite of B, which is 6, over 2 times negative 3/4. Okay, so what I would recommend that you do is simplify this part in the parentheses. Okay, so let me just come over here and maybe use this white space. The opposite of 6 divided by, and if you multiply this together, 2 times negative 3/4, you get negative 6/4. Okay, and we'll just keep on working with this. Remember what it means to divide by a fraction. Sorry, my board is going a little crazy. Dividing by negative 6/4, just write it out this way. 6 divided by negative 6/4 is the same thing as, you always change this to multiplication and then flip the fraction over. So we would change division by this fraction into multiplication by its inverse. And now you can see that really the result of that is negative 4. So we need, for our AOS, the opposite of negative 4. So the AOS is going to be the line x equals 4. Okay? So remember, it's the opposite of B over 2A. And a lot of people end up putting the AOS on the opposite side of the y-axis because they forget about doing the opposite of. Okay, so there's my line x equals 4. And so the vertex is on this dotted line. So that's going to be my second step. Well, where is the vertex on my AOS? It's got to be the ordered pair 4 and then some number for y. Well, to get that number for y, I'm going to take my AOS number of 4 and I'm going to plug it into the function. Okay, and whatever comes out for y will be the y coordinate of the vertex. Okay, so remember, you do powers first, and I'm just going to write this out in steps. Alright, so I did the 4 squared, and now I'm going to multiply negative 3/4 times 16, and so we can do a little canceling here. 4 goes into both 4 and 16. Alright, so negative 3 times 4 is negative 12, plus 24, plus 6. Alright, and so we got negative 12 plus 24, which is positive 12, plus 6, which is 18. Okay, well obviously on the graph paper that you have and on the graph section that I'm working with, I do not have 18 lines. So I'm not going to change the x-axis, that's not necessary, but I am going to change the y-axis so that it's in 2's. Okay, y-axis will be in 2's. So really, that's like going up 9, 2, 4, 6, 8, 9. Because of symmetry, I have a matching point the same distance away from the AOS. Alright, and let's see, I forgot to plot my, oh, I'm sorry, I'm getting a little bit ahead of myself here. Here's 4, 18. 2, 4, 6, 2, 4, 6, 8, 9. Okay. I was plotting the y-intercept. That was a bad move. Alright, we just plotted the vertex of 418. Notice that the a term, the number in front of x squared, is negative, so this represents the highest point on the parabola. The parabola is going to open down from this point. Okay, so we have, in this case, we have a maximum. You didn't have to identify it in this problem, but again, just giving you a look ahead to the last three problems. Okay? All right, so we have our AOS, we have our vertex, and now we're going to plot the y-intercept. That's an easy point to plot. The y-intercept is found by just doing 0 and then whatever the constant is. In this case, the constant is 6. So the 0.06 is the y-intercept, but remember we are in twos, so 2, 4, 6, and the matching point. Okay, we're almost there. We got 3 of our 5 points, and so I'm going to choose a number for x that is somewhere in between my y-intercept and the AOS, and really doesn't matter what you pick. I'm just going to split the difference. Okay, I'm going to go with x equals 2. I like to build from the AOS outward and try not to have any gaps as much as possible. So let's see what we get. For our fourth step, we're going to just think of this little table of values, and we're going to let our input value be 2. Okay, so let's see what we get for y when we plug in 2 for x. Maybe we can do this mentally. Okay, here we are. We got 2 here. 2 squared is 4, and negative 3/4 times 4. Negative 3/4 times 4, as you can see, it's just negative 3. Okay. All right, so we've got this part plus 6 times 2, which is 12, plus the constant 6. All right, so now just go left to right, and negative 3 plus 12 is 9, plus 6 is 15. 2, 4, 6, 8, 10, 12, 14, and here's 15. So that would be the point 2, 15, and then there's a matching point the same distance on the other side of the AOS. All right, now we have all we need, and so we connect our dots with this upside down U-shape. So that should be your final answer for number 18. Okay, and then I've chosen one more, and this one has just an additional step. We've been doing it already, but on these you're required to have the additional step of providing either the maximum or the minimum. Well, you'll know since a is negative, the parabola opens upside down, so we know there's going to be a maximum. The vertex will be at the very top of the parabola. The maximum is just whatever the y-coordinate of the vertex happens to be. Okay, so let's go through the routine. What's the AOS? Opposite of b over 2a. B is negative 3. A is negative 2. Inside the parentheses, I have really positive 3/4 because it's negative divided by negative. Positive 3/4, but this says to do the opposite of that. So that's going to be negative 3/4. All right, so let's approximate where we think x equals negative 3/4 is. It's not quite to negative 1. So do your best to just do an approximation. Okay, so x is negative 3/4, the AOS. Okay, now let's find the vertex, which is on this x equals negative 3/4 line, and here's how we find it. We just plug negative 3/4 in for x. Okay, and then we're going to, doesn't look real good, back that up a little bit. So you can see the negative sign. All right, plus 4. Okay, powers first. Negative 2 times, if you square negative 3/4, that's 9/16. 9/16. Okay. Negative 3 times negative 3/4 is going to be positive 9/4, and then plus 4. Alright, and got a little bit more work to do. This is going to be negative 18/16. Okay, and you could go ahead and reduce that if you like. Notice that 2 goes into both of these, so you could just change this to negative 9/8. So I think I'm going to do that if that's okay. Negative 9/8. And since we need a common denominator, let's go ahead and change 9/4 into 8ths. Okay. To make a denominator of 8, you would need to multiply 4 by 2, which means you need to also multiply 9 by 2. That's 18/8. And we need to change this into 8ths. So 1 times 8 and 4 times 8, that makes positive 4. Alright, a lot of work to do on this one. So negative 9 plus 18 is 9, and then 9 plus 32 is 41/8. Okay, so if we thought about that in terms of a mixed number, 8 goes into 41 5 times, so it would be 5 1/8. So the vertex is going to be negative 3/4, positive 5 1/8. Alright, so here we are at negative 3/4, 1, 2, 3, 4, 5, and then just a little bit more. Just approximate where you think that is. Alright, and again, remember that's our highest point, so we can go ahead and identify the max. The maximum occurs at 5 1/8, just the y-coordinate of the vertex. Alright, so let's see if we can get some more points. The easy point is the y-intercept. Remember, the y-intercept is found by just letting the y-coordinate of this point be the constant. So the y-intercept is going to be the point 0, 4, which is here. And that's 3/4 away, so we should do another 3/4, actually to a half. So the same distance away on the other side of the AOS, we should have a matching point. Okay, so they're both 3/4 of a unit away from the AOS. And then finally, we just need another value to plug in for x. Let's make our little table here, and let's just go with x equals 1. What is the output when we let x equal 1? Maybe I'll just do that up here. Let's see, negative 2 times 1 squared minus 3 times 1 plus 4. Okay, that's just negative 2 minus 3 plus 4. Negative 5 plus 4 is negative 1. Alright, so for an input value of positive 1, we get an output of negative 1. And that is, you can see that this is 3/4 and that's 1, so 1/4 plus 1, that's 1 1/4, and then another halfway over gets us our matching point. And so there is our parabola. There's the final answer, including the additional step that they ask us to find, what is either the maximum or the minimum. Okay, so I hope that helps out. I hope you get these right, and just let me know if you have any questions.